Okay, hi again. Now that we understand what is the purpose of this training, let's look at the data and let's do some coding. In Unit 3, we talked in details about linear models. We realized that we need to find the optimized values for coefficients and everything like that. And there were some mathematics we had to do. Instead of doing these things, which they are totally fine, but instead of doing those things from scratch, we can use scikit-learn, a Python library, in which it does the whole optimization for us and gives us the optimum value of coefficients for this for any linear problem. Um, that being said, scikit-learn has its own data sets too, which if you go through it, you will see lots of different examples and data sets. We are going to actually use the Boston Housing data within scikit-learn data sets as well. In this case, we only need to do to import the Boston data using from the scikit-learn.datasets. The other libraries that we are going to see here are Matplotlib and Seaborn for data visualization and Pandas to make the data frame. So now I'm going to load our data. I call the data set Boston. And I'm going to look what's inside this Boston guy. So the data type looks a bit weird, but that's okay. We are going to make it into a Panda data frame. It is just good to see there is this data part, meaning it gives us the features or variables for each house. And this one is target or the price of each house. And here we see the featured names. So I'm going to get a description of this data. Here I will see that we have about 500 houses and their pricing, as well as for each house we have 13 features or variables. For example, we have a CRIM, which is a per capita crime rate by town, or we have RM here, which is average number of rooms, and many others that you can see. I am going to make a data frame here for only features. So as I mentioned, because we are going to do a model training, I will have I have an X and I have a Y. So X will be all the features or variables and Y will be the target values. This is good maybe to have two different data frames as well. One of the data frames showing all the features and the other one the target values. That is what I did here actually. Make one data frame, call it Boston DF for features, and then target DF, which is for prices. Now we can go ahead and see what is the distribution of actually these prices, these housing prices. And we can make a histogram of that. As you can see, this is this pricing kind of is normal. We have some outliers here and there. One of them is here, as you can see. It is like what the high-end pricing of houses. And knowing these things, we have decided to see if we can use linear regression to train the model. Again, we are using scikit-learn library. So this is scikit-learn.linear model, and then we are importing linear regression. There are some steps we have to take when we are going to use scikit-learn library for that purpose. First thing is we are going to create a linear regression object. So this is, we need this object because when we have this object, then we are able to do fitting, to do predicting, and many other things. After that, we are going to fit, so using lreg.fit of X-train and Y-train. So this step is equivalent of writing the whole mathematics of these equations and try to do the optimization where we get our intercept and slope value for just y equals mx plus b example. Here, because we have more than one feature, we expect to have more coefficient values, and using lreg.fit will give us all coefficients for each of these features. And then we can do lreg.predict x test, meaning that using the trained model, we want to predict what will be the y or the target knowing this x test. Remember, the idea is that in the test part, we are using data that the algorithm has never seen before. And then we can use lreg.score to give us the R squared of this model, the fit. So again, I call X and Y for price or target and for features. Here I'm bringing on the object linear regression one. I'm adding the parameter normalized to be true. So we have different parameters within this object that we can change. You can see the scikit-learn website or the documentation for that I will put the line here as well for it. But in short, normalized equals true, meaning that before using features X here, we are going to normalize them. It is quite helpful, and we might talk about that later as well. So the other thing is that our data frame has 500 or a bit more than 500 housings in it, and we want to make a model out of it. So we realize that we need training and test set. For this case, we need to choose some of these houses and their features for training and some others for test. So the idea is that we want to sample, like we want to randomly take some of these for train and some of them for test. Again, scikit-learn provides us with the right way of doing that. We can import the so-called train test split function. And what we are doing is that we tell this function that we have X, we have Y, and we want to assign 30% of the whole data to be the test. And this way, it can go ahead and gives us X, Y train and X and Y test sets. Now we are going to train our model, meaning just doing lreg.fit for X train and Y train. Now that we have done this, we can do lreg.coef, which you can see it gives us 13. Let me see it. I take the length of this, which is just 13 coefficients, meaning for each feature, we get an optimized coefficient as well. So I can see what is this coefficient estimation for each feature here. And you see some of these coefficients are much larger than the other ones. Remember, we talked about it in Unit 2 when we were talking about feature importance. So definitely if a coefficient is larger, it means that that is more important. And the positive and negative values here shows if this is a positive relation or negative relation. For example, for room, we see that this is positive, meaning that if number of rooms are bigger or we have more rooms, the price will be larger too, which is quite common sense. And for example, for tax, it's negative. It means that if you have to pay more tax for this place, then the prediction gives us a negative value for it. However, this negative value is quite small. So now that we have these, let's do the prediction. So what does it mean? It means that now I have my model, meaning that I have all these coefficients in this equation of, so remember we had y equals mx plus b when we only have one feature. Now this equation will have multiple of these coefficients, Now that we have these coefficients and the intercept, we want to see using these values and having our X test, meaning feature test, can we find Y-pred or not? Well, definitely we can find Y-pred. We want to see if this prediction is good or not. One way to do that is actually looking at this, the residual plot that again we talked about in Unit 2. Remember that we said that a good residual plot is a residual plot that doesn't, when you look at it, it doesn't have any specific pattern, which is the case here. You can see that we have pretty much a symmetric behavior on positive and negative side, and you can see that it is between 5 and -5 with some outliers here and there. So in summary, what we did today was we attempted to train a linear model so that we can predict the price of a house, a new house, when we have its features. Hope that helped you and you understand how easily we can implement this method.